So good afternoon everybody, myself Acharya Vishvendra. Today I'll discuss the concept of orbital speed and all the concerned information, the graphs, analysis and the questions, the basic level questions. So orbital speed is the speed required to move a satellite around a given planet. Suppose this is a planet of mass capital M and we want to move a satellite of mass m dash with a certain speed v. The first question is we need to give it certain speed, because if speed is not there, gravity will attract it and it will ultimately reach to m. So if we want to make it move, we give it a speed so that the gravitational force is utilized in giving the centripetal force, and using that expression, the expression for orbital speed comes out to be root gm by r. Now let's see the graphical analysis of that. So suppose that we want to draw a graph between v and m. So we can see that v is proportional to root m. VO, it should be here. So we can see that VO is proportional to root m as given in this formula. So the graph between v0 and m will be a parabola turning toward m axis. Then if we draw a graph between v0 and root m, so suppose root m is equal to x. So we have v0 proportional to root m, which gives proportionality to x. So graph between v0 and root m will be a straight line. Then we have a relation with the distance. So as we can see over here that v0 is proportional to 1 by root r. That means graph will be having a shape like rectangular hyperbola. So it will be like this. However, if we draw a graph between v0 and 1 by root r, so we suppose that root r is equal to x here. So we have v0 proportional to 1 by x. So the graph will be a rectangular hyperbola exactly like this. Now if we draw the graph between v and 1 by root r, so we suppose that 1 by root r is equal to x. So we have v proportional to x. So graph will be a straight line. However, if we draw a graph between v and 1 by r, so we just assume that 1 by r is equal to x, which gives 1 by root r is equal to root x, which gives v proportional to root x. So the graph will be a parabola turning toward x-axis. Now there are certain mathematical relations for that. Near surface of earth, we take r is equals to 6400 km. So if you substitute this value, the orbital speed comes out to be about 7.9 km per second. This question has been asked in many competitive exams, so you must remember it. There is one important thing, that v0 is independent of mass of satellite, because here we can see that mass of satellite is m dash, and in this expression there is no involvement of m dash. That means orbital speed is independent of the